Okay, so carrying on with my history project, the history of chemistry and medicine is a huge focus. So I found an article that I need to reference later, and it was not PubMed, it was straight from the NIH. Oh, interesting. Do we have two different NIH websites? One is pubmed.ncbi.nim.nih.gov, but that's not the article. Let me just Google the same thing I did then. Okay, so it's central nervous system targets and supraspinal mechanisms of analgesia, like a pain reliever, however you pronounce it. Okay, maybe, nope, this was not it. Because it was highlighted actually just a moment ago when I Googled it, it was highlighted that there is an extreme deficiency in responding to the wide variety of supraspinal medications and side effects that patients have, whether it's a pain reliever, an anticonvulsant, and whatever the other one was, because I got to take gabapentin, prescribed gabapentin, and so I got to learn a little bit more about it. So that one's an anticonvulsant, and it's super unique. I've never tried anything like it, and I've tried a lot. It actually like affected my mania, so it actually relaxed me so much that it stressed me out, so I had to lower my dose. All right, next topic. Okay, so here's the AI overview of supraspinal research, because I did want to reference an article. So I'm just going to read the AI article, and then I think that I might have found it because I think I Googled supraspinal research. So supraspinal research investigates how the brain modulates signals from the spinal cord to influence functions like pain, movement, and emotions. And then we'll see if this is the NIH one I was reading. No. This is why I appreciate a lot of the articles in NIH, though. They're so honest and nobody talks in the reality of them. For example, the NIH describes side effects from antidepressant medication. They have a page of symptoms of unattractiveness, because I started getting like peach fuzz and gaining weight. These are all listed under the NIH description of antidepressants as symptoms of unattractiveness, which is a great way to cure depression. So I'm just going to read a little bit of the NIH research comprehensive review on supraspinal medications. The main supraspinal regions involved in processing pain include the primary and secondary somatosensory cortices, primary and supplementary motor cortices, insular cortex, prefrontal cortex, parietal cortex, anterior cingulate cortex, thalamus, amygdala, hippocampus, and basal ganglia. That's pretty much all of them. Pain's an important part of being alive. and, processing information. The thalamus and anterior cingulate cortex play a role in registering stimuli as painful, while the somatosensory cortex distinguishes non-painful stimuli. One study showed that the primary somatosensory cortex and the insular cortex had increased activity associated with the intensity of a painful stimulus. This is a part I'm going to jump to. The motor and supplementary motor cortices are thought to process the motivational or escape aspects of experiencing pain, while the prefrontal cortex likely drives descending modulations of pain. And like the AI said, and it's true, because I'm prescribed gabapentin for PTSD right now. So I'm subscribed it for a stress disorder. And so it's interesting that we're so far behind in how we translate the studies of the brain. And we went way over our britches, obviously, with Operation Paperclip and MK Ultra, and just continuing to experiment on the vulnerable. And so this is nice where it's like to be reading medical journals again, because we notice that it's likely that this causes, motivation, which is such a hard thing to measure. And that's the motivation for escaping pain, but then you have the whole pain is pleasure reality. So it's not that pain is always wanted to be escaped. It depends on the kind of pain. So this is interesting, and somewhere in this article it talks about the lack of the ability to really understand how these complex regions in the brain, all those brain systems I've read that communicate stimuli, we don't understand that, and we definitely don't understand it person to person. So that was all there, and we have the audacity to court order people to take medications. What year was the first civil commitment in America? I'm gonna let people guess. Civil War, 1860. No surprise there. And then, of course, a lot of times it was women being committed by their husbands. So the AI is saying it was a 1860 case with Miss Elizabeth Parsons. Miss Elizabeth Parsons Ware Packard, probably married her cousin, became a landmark example of a problematic civil commitment, as she was committed to an Illinois asylum by her husband under an old law that allowed married women to be committed without proof of mental illness. That went along, and then it thrived in the 60s and 70s. And just a point of fact, we have electric shock therapy in the state of Minnesota that can be ordered by civil commitment. So my next topic, because I was just like wanting, I'm actually moving forward to get back to what I've been doing in 2022 academically. Amazing. Back to myself. I'm on my X, and I haven't been on social media a lot, so I get kind of a few followers pretty often on X, and yeah, so, and like Pulsar Helium, which is a new helium mine out of Topaz, Minnesota. Every now and then they'll like something because nobody engages with them, and I kind of want X to have that chemist, physicist, I want that to dominate over the politics. because X is like just dominated by politics, and it's like the cornerstone of politics really is chemistry and physics, because that's what great economies are built on. All right, so the other concept I had been working on, and I'm happy to get back to it, is acceleration in chemistry. So I just posted on X, acceleration in chemistry. I'm working on understanding how we grapple with new compounds, just compounds in general, especially the compounds and the characteristic in chemistry of accelerating, also change in direction. And I might be redundant there, accelerating, if I'm remembering it right, implies a change in direction. Well, it's velocity, which I still have to like really grasp that concept. Okay, so I found a really interesting article by ACS Publications. So it's pubs.acs.org, and it's a journal of physical chemistry, and this is from November 7th, 2023, and it's also copyrighted by the American Chemical Society, which I think is our top group right now, at least publicly, for chemistry. 1,600 people have viewed the article. Okay. Yeah, I'm going to read a little bit of it. I read a tiny bit and then I forgot. And then I was like, I better read the video and kind of get used to getting back into this mindset in case myself I want to change directions out of history. I had originally been in chemistry and then I changed because I couldn't handle it focusing at the time. Anyway, over the years, this is from the article. Excuse me. Actually, I can show it. Let me see it. This little thing there. Okay. This is fun. Over the years, many computational strategies have been employed to elucidate reaction networks. One of these methods is accelerated molecular dynamics, which can circumvent the expense required in dynamics to find all reactants and products. So I did a video and I was like, well, how do we know how we're making chemical compounds safe for commercial use? Like, what's the process? So I'm happy to have gotten a little closer myself to understanding. Okay, so they're trying to do this in the computer. So over the years, many computational strategies have been employed to elucidate reaction networks. One of these methods is accelerated molecular dynamics, which can circumvent the expense required in dynamics to find all reactants and products and transition states on a potential energy surface by using fictitious forces that promote reaction events. Okay, so I'm gonna be a little out of my league for the rest of this because I'm losing the language in it. There was a more simple definition, so I'll end with that. Okay. Acceleration in chemistry. Yeah, AI is fun, but it's obviously going to be a huge problem, which is good because we can debate what is known, what has been fabricated. Okay, so in chemistry, acceleration primarily refers to a substance, often called a catalyst or activator, that increases the rate of a chemical reaction. The term is used to describe how quickly a reaction proceeds, which is a key concept in the study of chemical kinetics. The AI goes on. The chemical definition of acceleration. With the term acceleration in physics refers to a change in an object's velocity. In chemistry, it is used colloquially to mean the increase in the speed of a reaction. The formal study, I'm just wondering about change in direction. The formal study of reaction Oh, the need for the electron, is that changing the direction? Like the need to take or give away, or I'm gonna order some books and then I'll be better at this. The formal study, I love this sort of thing though. The formal study of reaction speeds is called chemical kinetics. So an accelerator is a substance that increases the speed of a chemical reaction, even in small amounts. Reaction rate, I'll end after 2 more points. A measure of how fast reaction rate, a measure of how fast reactants are consumed and products are formed over time. Autoacceleration, a phenomenon in some polymerization reactions where the reaction rate increases over time without external factors due to the buildup of reactive species. My like the first man I loved became a chemist, and so it's nice to like honor the science in my personal respect for the work people sacrifice their entire life to do. I don't know what kind of person that man is today, but I do know that he's still a chemist. I don't think a lot of them are able to do much. I think a lot of them are like, this is what we have. You can come to the lab and measure and write down things, or you can, not. So, yeah, that was it. I'm going to watch Kill Bill. I'm really excited. I haven't seen it in a while. It's one of my favorite movies. Okay.